Tonight we're going to learn about solving quadratic equations by factoring. So we already know how to solve a quadratic equation by graphing, and today we're going to learn the most widely used method, which is factoring. Here's an example of a quadratic that's been factored. I've got x plus 5 times x minus 2 equals 0. So we have what is known as the zero product property, which will help us solve this quadratic. The zero product property tells us that if the product of two quantities equals 0, then at least one of those quantities equals 0. So I have if A times B equals 0, then either A has to be 0 or B has to be 0 in order for the product of those two numbers to equal 0. And that should make some sense. So I know, using the zero product property, that x plus 5 times x minus 2 equals 0 means that one of these factors has to be equal to 0. So either x plus 5 equals 0 or x minus 2 equals 0. So if that's the case, then for solving for x, I know that x either equals negative 5, remember bringing this over to the other side, or x equals 2. Now I'm going to want to check by substituting back in. So I'm going to substitute back in my negative 5. So I have negative 5 plus 5 times, negative 5 minus 2. So 0 times negative 7 does in fact equal 0. Or I can plug 2 back in. 2 plus 5 times 2 minus 2, or 7 times 0 does in fact equal 0. So we're going to follow 4 steps every time. We're going to set everything equal to 0. We're going to factor, then set the factors equal to 0, and solve. It should be fairly clear. So let's try one. I've got x squared plus 8 equals 12. I'm going to factor that out to x plus 6 and x plus 2, set that equal to 0. I now know that either x plus 6 will equal 0 or x plus 2 equals 0. Now I'm going to solve. X either equals negative 6 or x equals negative 2. And remember, I'm going to check by substituting back in. I can even plug this number back straight into my quadratic equation. Negative 6 squared is 36, plus 8 times negative 6, or negative 48, plus 12 does in fact equal 0. I can plug in my negative 2. 4 minus 16 plus 12 also equals 0. So I have checked to make sure that I have factored this correctly. So here's another example, except that I can't immediately factor. We saw this in class yesterday. I need to take out my greatest common factor first. So I'm going to take out my 3, which will leave me with x squared plus 2x plus 1 equals 0. Now, I've got this 3 in the middle, in the beginning, which means I really should be dividing both sides by 3 to get rid of it. Well, this 0 divided by 3 is still 0, which means that x squared plus 2x plus 1 still equals 0. Okay, so I've taken out my 3, my greatest common factor. Dividing by 3, I still have 0. So now I just have this set equal to 0. I'm going to factor it to x plus 1 times x plus 1, or x plus 1 squared equals 0. So I know that either x plus 1 equals 0 or x plus 1 equals 0. Therefore, they're both equal to negative 1. I have just one factor, and what does that mean? It means with one solution, I only have one 0. So I have a parabola that's going to touch my graph at negative 1 and not cross it twice. I only have one solution. Again, so I have one solution, and we can check this by graphing. Plug it into your graphing calculator and see if you come up with something that looks similar. Pause the video here and try these out. Solve by factoring. So in this first one, I have two solutions. X either equals x equals 4 or x equals 2. So I have two solutions. In the second quadratic, I've got just x minus 6 squared, so x equals 6. I've got one solution, which remember means I'm just touching the x-axis. Here I've actually crossed the x-axis, which is the two solutions. Now in this case, I decided to move my 2x squared to the other side so that I had a positive x squared, or a smiley face parabola. And I found that my solution was x equals -5. What you would have noticed if you had brought the 20x and the 50 over to the left-hand side is you would have had the exact same parabola, only it would have been a reflection across the x-axis. So it would have been, instead of a right side up parabola at x equals -5, it would have been an upside down parabola at x equals -5, and that should actually be touching. I apologize for my poor picture, but that would actually be the same parabola, only flipped on either side of the x-axis. So let's look at an application problem. I've got a diver's height above the water modeled by this quadratic function, where h is the height in feet and t is the time in seconds. So I want to find the time that it takes the diver to reach the water. We've done this by graphing, but let's do this by factoring. Well, notice here I've got a greatest common factor. After setting this equal to 0, I notice that I can take a -8 out. So -8, now I've got 2 t squared minus t minus 1 equals 0. Remember, I divide by -8, and of course that means I've got 2t squared minus t minus 1 equals 0. This is going to factor to 2t plus 1 and t minus 1. So I've got two solutions. I have 2t plus 1 equals 0, or I've got t minus 1 equals 0. So 2t equals -1, or t equals -1/2, and t equals 1. Well, let's think about that. T is time in seconds, and this solution gives me -seconds, which means this is actually not a viable solution. So my only answer is 1. So it will take the diver 1 second to reach the water. Here's an opportunity for you to try it. Pause your video and see if you can figure out how long it takes the rocket to reach the ground at the bottom of the cliff. So once again, I have two possible solutions. I either have t equals 5, so it either takes 5 seconds to reach the bottom of the cliff, or -2 seconds. So that -2 is not going to work. It will in fact take 5 seconds for the rocket to hit the bottom of the cliff. Okay, so you've got your homework for tomorrow, but the joke that you have all been waiting for, what did the acorn say when it grew up? Geometry. Get it? Geometry. I'll see you tomorrow. Please bring these in on with your notes.